Okay, Assalamualaikum and hello. So today we continue with the chapter 7, which is graphic. Okay, so you already learned about the how to create data, how to operate, okay, how to create a function, how to save and load data. Okay, so now you have to process the data in the form of graphic, like a chart or bar graph. Okay, so today we will learn about that. So the objective here is to plot a two-dimension. Okay, let me maximize this. Okay, and then to subplot. Okay, so subplot is basically one figure. You have multiple plot, and then you have a specialized 2D plot, which is stem graph, log graph. Okay, logarithmic graph. Okay, Histogram is the bar graph, and there are other, but only for this course they only focus on this graph. And also lastly, you will learn about figure editing using wizard. So you will learn about the code first, okay, and then you learn about using wizard. Okay, we start with the introduction. So why plotting? So pictorial way to representing relationship between various qualities. Okay, so summarize the huge information into one picture, easier to analyze. Okay, and you can easily compare multiple measurement. So that is the why we plot some data. So scientific data, in scientific data, each recorded value is called sample. Okay, so practically each sample is recorded according to the change of parameter like time, angle, distance. I think most of this you already know. So for example here, VT, voltage against time. So V is y-axis, T is x-axis. Okay. So because this is we focus on 2D, so you have a two variable as a measured value itself and the function variable. So basically you have x and you have y. Okay, I think all of you already know about this. Okay. And then this is an example of scientific data. Temperature recorded every 0.5 second for 1 minute. So you can see here, x-axis is the time. So 0 and the time is 0.5, the step until 1 minute. 1 minute is 60 seconds. So the number of sample is 121. Okay, and the measured is the y-axis, so the temperature. It goes something like this. Okay, voltage. Okay, if you measure a voltage output of a RC circuit for 20 value, frequency range from 10 to 100. So you can see here, the x-axis is the frequency from 10 with a step of 100, okay, until 20. Okay. So 10 to 100, okay, with a step of 20. Line space is linearly spaced. Okay, you have 20 point of data, 20 number of sample, and you have the voltage. Same here. So either you use this kind of coding or you can use line space. Okay. So number of chair in the classroom 1 until classroom 10. So this one is you use histogram to represent this different classroom and the total number of chair. Okay, number of sample is 10 because you have 10 classroom. Okay, plotting data. Plotting data, of course, you have y-axis, the measured variable, and x-axis, the function variable. Okay, I think this one also you already know. Okay, both main variable and function variable vector must have the same length. This is important when you plot. Okay, when you plot, the x and y data needs to be the same length. Okay, if the y is 1 multiplied by 10, x also needs to be 1 multiplied by 10. If not, you cannot plot the data, it will be error. Okay, we move on to the next part, which is 2D plot. Okay, so what is 2D plot? Is basically a standard plot. Okay, the spacing is linear. Okay, so basically you can see here, you just use plot, open bracket, the x data, comma, and the y data. And sometimes you can put a line spec. Okay, Line spec, I will show you later, line spec, so no need to worry. But the line spec is not compulsory. Basically, you just put X and then comma and Y. Okay, this is your variable. Okay. So here is the example here. You can try it. X is 1 until 10, means that X is 1, 2, 3, 4, 5 until 10. And the X value is inserted into here. Exponential, exp is exponential. Okay, X divided by 2, this one, this equation. Okay, so basically you just create X data. X is the manipulated data, Y is the response. Okay, response data. Okay, or in this case it is called measured variable. This one is a function variable. Okay, depend on you. It's not okay. So you can use plot, open bracket, X and Y. X and Y is not compulsory. You can use A and B. It's okay also. Okay, so you can see here you get the data, and you can see here it's not very smooth. Why? Because the step is not enough. So if the step is not enough, maybe you want to change the step is to 0.1 instead of 1. So 1 double dot 0.1 double dot and 10. So that is how you get a smoother, okay, smoother plot. So let's move on to the line spec. So if you recall back here, X, Y, you put a line spec. So basically you change the spec of the line. Okay, so for the line you can have a solid line, which is just a dash, or you have a dash line, okay, double dash, or you have dot line, you have double dot. Okay, and dash and dot, okay, you can use this one. Okay, you can try it. And this is for color. You want to change the color of your plot here. This one is default by blue, but if you want to change it to red, green, blue, and magenta, yellow, you can change it, okay, using this one. And you also can add marker. So you here there is no marker, so if you want to add marker, it will, for example, just add X into the data point. Okay, so you can plus, circle, asterisk, point, cross, something like this. Okay, so line spec you can adjust it whatever you want. So let us look here. So you can see here X is 10, 1, starting from 1, and the step of 10 until 500. See, okay, the step is 10 starting from 1. Okay, and Y is sine 5x. Okay, so you plot it. Okay, and you put X, you put Y data here, and you open bracket here. Okay, okay, this one. Okay, so you want a continuous line, so you just put 1 dash and then M, magenta. Okay, and the mark is O. Okay, so if you recall here, solid line, okay, dash, 1 dash only. Okay, magenta, M, and then circle. Okay, the marker is circle 0. Oh, not 0, O. Okay, so you will get this line. So its color is magenta. Okay, so magenta. Okay, and they have circle mark and the line is solid. So that is how you adjust the line spec. Okay, you can try it on your own. Okay, one more thing. Okay, so if you look here, this time Y plot Y doesn't work. Okay, so you can see here, actually you can plot Y only here. Okay, so you can plot Y. Okay, but it still get the same result. Why? Because if you just plot Y, okay, automatically X will start from 1, 2, 3, 4, 5, 6, 7. So this is the default if you only include Y. Okay, so if you have different types of X, okay, difference means that it's not start with 1 and the step is 1. Okay, like this. Okay, you cannot just put plot Y. Okay, For example, this one is 1 with the step of, it start with 1 is okay, but the step is 10, so it's not okay. So if you plot y, it will y only, okay, you will not get the result. So I hope you know the difference. Okay, and another thing that you know need to know is plot formatting. Okay, this is plot formatting. Basically, if you want to add something in the plot, you can code it. Okay, you can just add code. So if you want to add title here, X label, okay, the title of X axis, the title of Y axis, legend, okay. If you want to add text, okay, and you have, if you want to add limits to the X and Y, X lim, Y lim, or you can use axis, okay. If you want to set both. Okay, and then you can add grid. Okay, you just write grid on. Okay, I will show you later. Okay, all of this I will show you later. And if you have multiple plots, you can just write figure. If you want to create another figure or you want to create a sub figure, you can just use subplot. Also, I will show you later. So 2D plot with server properties. So I will show you the first one, how to use plot formatting. So you can see here, W is equals to line space from 0, the step is 2 pi until 100, until 1000, and Y will include to sine W. Make sure you know that W is in radian. Okay, sorry about that. This is line space. So line space is basically from 0 until 2 pi with 1000 data. Okay, 1000 sample. So if you use line space, linear space, okay, lin space, you will start, you write the start point, end point, and how many data you want. Okay, and then you save it in Y. You save it in W. And then you plot the Y. Y is basically use the W in the sign. Okay, and you want to plot W divided by pi and Y. So basically you want to change the W to pi, to remove the pi, okay. Just remove the pi because easier for you to plot later. Okay, so X label. Okay, so what is X label? You just label X here. So X label is here, and then open bracket with the open bracket, and then this parenthesis, if not second parenthesis, okay, you have to put this, okay, and then backslash. Remember, backslash are the upper sides of enter. Make sure you use the correct slash. Normal slash is near the shift, okay, but backslash is for if you want to use the symbol. And you put omega here. Okay, and make sure you know the reference. If not mistaken, omega and capital letter O, omega is different. Okay, so Y label, of course, this one, the Y label side. Okay, so sine, open bracket, and omega. Okay, backslash. Okay, and parenthesis and close. Okay. So make sure you know how to use this. This is just X label and Y label. Okay, doesn't need to be in one. Okay, so let me show you. Of course, recall back if you want to do coding in real life. Okay, in exam no need. Okay, but in real life, in here, you have to here CLC and close all. It's just to clear everything up. Okay. Okay, and then you paste it. Okay. Of course, same as before, you have to change this. Okay. Just rewrite it again. Okay. So you can see here, maybe I just put a breakpoint here. Okay. So run it. It will create data W and Y. So divide by pi is basically just remove the pi. So instead of 2 pi, it's just 2. Okay, easier. Okay, so this one I suggest don't do like this. May get confused. So you just create a new line, so easier. Okay, so you can see here, okay, when you plot it, it will create a figure. Okay, so you can see here, it will create a figure without any label. So if you press this, okay, X label, okay, it will run X label, automatically it will create this one. Okay, so let me check. If you use capital letter, it will show a different one. See, it is now ohm. Okay, ohm symbol. So make sure you use the correct one. Okay, this one is small letter to create a omega. Okay, okay, and then you can see here. Okay, and then for Y label, it will create a Y label here. Same here, only sign, open bracket, omega. Okay, so it will create sign omega. So for the X tick format is a little bit tricky. Okay. Okay, this one, if you can see here, is this one is the label. Okay, in radian. Okay, remember 2 pi, but there is no pi here, right? So if you want to add pi here, okay, how to do this? Okay, if you want to reformat what is writing right now, you can just use X tick format. Okay, so X tick format. Okay, percent, remember, recall back, output, input and output, f print f, remember. So percent dot 2, okay, 2 decimal point is taken, dot 2, and f is the floating number. Okay, so percentage, don't forget, percentage to f. Okay, and then backslash x3c. Oh, this one is, if not mistaken, is pi. Okay, so backslash x3c. Oh, so it will create pi. So let me check. So you can see here, it will take 2 decimal point. Okay, 2 decimal point, and it will add pi. So that is how you change the format for the X tick. Okay, and then the title. Okay, so title is basically open bracket. Okay, you add the title at the top. Okay, so sign, okay, omega, this one is just a symbol, and then graph. Okay, let me run this. So sign w graph. Okay, so there is no grid here, you just write grid on. Okay, so it will create a grid. Okay, you can make it larger, you can make it smaller. Okay, so if the tick too much, minimize it. Okay, so make it smaller. Okay, and if you want to copy this, I suggest don't save it. You can save it, save as, okay, save as a JPEG. Okay, if you want to save it as JPEG, it will create a JPEG here. Okay, this is the JPEG. Okay, it's not very good. Okay, but if you want to have a very high quality, okay, file, go to edit, sorry, not file, edit, copy figure. Okay, so copy figure, you open a Word file, then paste. So you can see it has higher quality. So I zoom in, it still have a higher quality. Okay, so that is how you copy the figure. So if you want to adjust the size, you cannot adjust it here, you adjust it here earlier. Okay, so for example, something like this, edit, copy for figure, and then P. So you have a better figure. So you have to adjust it before you copy it. Okay. Okay, so we continue. Okay, multiple plot in a single graph. So maybe let's take a break. Okay, so make sure you slide in your attendance. Okay, I will put it in e-learning. Okay, I will put it in e-learning. Okay, you can slide in your attendance. So take a break for 5 minutes. Okay, so you take your 5 minutes on your own. Okay, So we continue with the multiple plot in a single graph. Okay, usually we want to compare some data. Okay, you want to compare one plot with another plot. So if you want to do that in MATLAB, okay, you just put plot, of course, x1, y1, line spec 1, and then you just continue with the x2, y2, line spec 2, and so on. So it is just continuous. Okay, and for the legend, okay, of course, when you have multiple plot, you need to have a legend, okay, to mark what is the plot is all about. So of course, you just put open bracket the plot number 1, what is the title here, and then plot number 2, and so on. Okay, so this is how you use the plot function with multiple plot. Okay, let's take a look in the plot. Okay, so this one is you want to visualize intersection between two polynomial. So basically you want to know the intersection of function f and g. Okay, and plot the graph for x from -10, -9.5, -8, and until 10. So first of all, you have to write what is x. So you can see here it starts from -10 and with 10. Okay, and the step is 0.5. Okay, positive 0.5 because it's increasing. So you have to write this. Okay, -10 with the step of 0.5 because it's increasing. It should be positive. If decreasing, it should be negative. Okay, and then until 10. So then you write the f function 3 multiplied by x dot power of 4. Okay, for this case, I think, yeah, you need to use what you call the array operation. So you have dot. Okay, if not, you have to do a for loop. Okay, so take time if you use for loop. Okay, recall back chapter 4 for loop. So better to use array operation. Okay, so much more easy. So this one you just copy back the equation. If you recall back your previous chapter, okay, how to write this array operation. Okay, so then move on to the G. Okay, you get the data x, f, and g. So now you have two plot. Okay, two plot here. Okay, so sorry. Okay, so you have two plot. Okay, I have to fix this. I think something wrong with the computer. Wait, Okay, so we continue. So you can see here plot x, of course, x and then y. So for this case, y1 is f. Okay, so you just put f and then the plot spec. Okay, so dash means that continuous line, x is the marker, M is the color, magenta. Okay, you can just put it here. Okay, and then x, you can use the same x, no problem here. Okay, x and then g. Okay, so this is the second plot, and for the second plot you have dash line. O is the marker with circle. K, if not mistaken, is black. Okay, black color plot. So after that, you put a legend here, fx and gx. So this one represent the first one, second one represent the second plot. Okay, so it should be something like this. Okay, so x label x, it should be x label x. Okay, the output should be something like this. Okay, you can put the title here. Of course, remember how to put the title. This one. Okay, and grid on. If you want to grid to be on, you put grid on. Okay, you can try it. Okay, we continue with the next part, which is subplot. Okay, so subplot function. Okay, so basically what is subplot? Okay, you can see here, this is one figure. You have two plot in one figure. That is the subplot. So subplot is basically you have M, N is the size of the subplot, and P is the position of the subplot. Okay. So let's use the subplot. Okay. So you have here, you have upper and lower subplot is defined by 2 by 1 grid. Okay. 2 by 1 means that you have 2 row 1 column. Okay. 2 row 1 column. So how to do this? Okay. So create a subplot of y equals to cos 3x and z equals to sin x for x equal to 1 until 10. So of course, this one is x equals to line space from 0 until 10. Okay. It should be, because it's already specified, but depend on the question actually. But for this case, it's choose to be 100. Okay, 100 point instead of 1 point only. So sorry, one step. Okay, so you can see here x and then y equals to cos 3x and z equals to sin x. So basically x, y, and z. So how to use it? So basically just subplot. Okay, subplot 2 row 1 column. Okay, so you can see here this is consistent. You need to make sure this is consistent when you use a subplot. Okay, if you choose 2 and 1, 2 row 1 column, the second one also needs to be 2 row 1 column. The only changes is the position. This is the position 1, this is the position 2. And the position, okay, I will show you later. Okay, I think the slide will show you how the position is shown. Okay, no need to worry. So just add subplot before you use the plot function. Okay, so let us look. Okay, so if I run this, okay, so subplot, so it will create a figure but at the top only. Okay, and then of course you add a title. Okay, maybe this one is a bit confusing. Instead of this, you just enter a new line. Okay, less confusing. So basically you just put subplot before you plot anything. Okay, you can plot or use any coding. Okay, just use subplot first before the plotting begin. So you can see here, okay, it creates subplot. Okay, and then you plot it at the title and subplot for the second position. This is the first position, second position. Okay, so basically position will fill out the row first. Okay, and then go to the second row. Okay, to the third row. Okay, so basically, let me pause it. Okay, if you plot a 2, 3, okay, for example here subplot 2, 3 means that, okay, this one is the position. Okay, so 2, 3, so basically 2 row 3 column. Okay, so be careful with this. So it should be something like this. Okay, and the position is 1, 2, 3. You complete the row first and then go to the next row. 4, 5, 6. Okay, so it will be different from index. So if you recall, index is 1, 2, 3, 4, 5, 6. So this is for indexing. Okay, but for subplot, it will be row first and then go to the next column. Sorry, complete the row. Okay, and then go to the next row. Okay, I hope you understand how to put the position here. Okay, so we complete the subplot. Okay, you have something like this, subplot. Okay, so next we have another example of subplot. Okay, this one is a little bit complicated. Okay, so this one, in analysis of RC circuit with a AC input voltage, 2 response is needed to be plotted. Okay, so no need to worry about this. Okay, equation. Okay, This is just an example. In the exam, the equation will be given. So you have a magnitude is 1 divided by square root of this one, and phase you have this one. Okay, the only change is the frequency. Okay, you only focus on the equation, no need to understand the theory for these courses. Okay, so in MATLAB we can use the function as ABS and angle automatically to compute magnitude and phase from hash. Okay, so if you, I don't know whether you already take a control or not. I think not yet. Control should be in the semester 5, I think. So when you have a RC circuit, okay, you want to analyze it in frequency domain instead of time domain. Okay, so time domain means that this one is in the time as before. So this one is considered as time domain. Okay, I don't have any example in time domain. Okay, so but this one is in frequency domain, and the characteristic equation is this one. Okay, if you learn about control, this is the characteristic equation. Okay, and if you want to have magnitude, this is the equation, and you want to have phase, this is the equation. Okay, so I think this one in this semester you will learn, no need to worry. Okay, you will learn this. Okay, but no need to understand it too much, but you can know that this is the original equation, this is the magnitude of this equation, this is the phase of this equation. Okay, in MATLAB you can automatically calculate this using ABS, absolute. Okay, so magnitude, you get the answer from this, and angle is this one. Okay, you have angle hash, you will get the answer automatically. Okay, magnitude is the ratio, no unit. On the other hand, unit phase is in radian. Okay, write a MATLAB script for plot both magnitude and phase when R equals to this one, C equals to this one, and F is changing from 0 to 10 kilohertz. So of course this is just a constant. Okay, and F is the variable here. Okay, and hash, you can use this one, the characteristic equation here. Okay, and then the magnitude of course you can just use F's hash. Okay, phase is also use angle. Okay, in radian. One thing you should know, this is in, because you can see here F is in vector, so you have to use array operation, which explain the dot here. Okay, so make sure you know how to write this equation, this one, into this one. Okay, don't forget this one, the what you call the array operation. And then of course you have to subplot 211 and 212. Okay, means that you have two row, okay, one column, subplot. Okay, and then plot, okay, F divided by 1000. Okay, F divided by 1000. Okay, so why F is divided by 1000? Okay, so basically because of the unit. Okay, so this one also no need to worry. Plot, okay, and then magnitude. Okay, just this one in frequency is in kilohertz, that's why it divide by 1000. Okay, and then you have put X label. Okay, and X sticks, of course. Remember, you divide by 1000 and you change it, instead of hertz you change it into kilohertz, and you take 0. Okay, dot 0 means that you don't have decimal point, so this one doesn't have decimal point. Okay, don't forget the percentage. Okay, and F is the floating number. Okay, that is the tick, and then Y is the magnitude. Okay, so this one is magnitude, is the Y, X, this one is the X. Same here. Okay, you change it. Okay, 5 phase divided by pi, you want to change the angle. Remember, this is in radian. when you use this code automatically in radian. MATLAB prefer radian instead of degree, so you have to change the radian into degree. How? You just divide by pi. Okay, this is x label. Okay, frequency. Okay, this one just tick the same thing. Now next is the phase, and the y tick format is, this one is pi. Okay, so it will come pi. Sorry, this one is not changing from pi to degree, it's just removing the pi as before, because you want to add pi. Okay, after this in the tick. Okay, so the plot we should become like this. Okay, so no need to worry. I think you also learn this in your semester, this semester, I think, about the RC circuit. Then you can practice plotting this in the class, in the programming class. Okay, let's take a look at the next example, which is called quadrant, also the subplot. Okay, so for this case, you will learn about how to plot a subplot for the same function, but multiple n frequency, I think, if not mistaken. Okay, so you can see here, plot a 4 sinusoidal signal for 4 different frequency. Okay, so you can see here you have 1 Hz, 2 Hz, 3 Hz, 4 Hz, 4 different type of frequency, and you put it in different plot. So you can see here, first quadrant, 2nd quadrant, 3rd quadrant, 4th quadrant. Okay, you have 2 multiplied by 2 grid subplot. Okay, so how to do this automatically? And of course you have to put the time first, 0. Okay, this is the step, and then until 1, and then for f equals to 1 until 4. So you can see here you have 4 types of frequency. Okay, 1 until 4. Y equals to sine 2 pi f t. Okay, so you can see here this is 1 Hz, 2 Hz, 3 Hz, 4 Hz. So f equals to 1 Hz, 2 Hz, 3 Hz, 4 Hz. So automatically, and then y equals to sine. Okay, plot. This is just a normal 2 pi f t. Okay, if you recall 2 pi f t. Okay, and then subplot. Okay, 2 multiplied by 2, and then you put f. F is the position. This is easier because f is 1 until 4. But if your frequency is not 1 until 4, 100, 200, 300, 400, for example, you have to create a different index. So recall back your chapter 4, I think. Okay, because when you use 4, of course you need to have a different separate index here if you have different frequency here. Okay, let me change this, I think. Okay, so let's take a look. So you can see here, plot the first one. Okay, and then label it y label. Okay, so if you can see here, for y label you use sprintf. Okay, sine 2, and then this is pi. Okay, and then %d. Okay, remember the placeholder. Okay, so %d and f. Okay, you just put the d. Okay, the f inside the d location. Okay, and y label just print out the sprintf. Same here, sprintf title %d and then cycle. Okay, so you just call it. So you can see here. Okay, if I run this one by one. Okay, and then now it's update to f equals to 2. Okay, it will plot the second one. Okay, it also update. Okay, recall back the sprintf. Okay, so how you use it in the plotting. Okay, same here. Okay, and the last one. Okay. Okay. I hope you understand how this works. Okay, basically you just manipulate the variable here to plot here with as print f. Okay, you have to recall back chapter 6, the previous chapter. Okay, we have completed the standard plot. So how about if you want to plot, okay, using a special type of plot? So this one is stem. Okay. So if you want to use stem, okay, maybe you should look here first. Okay. So stem plot is something like this. Okay. So this is your data point. Okay. It will plot something like this. Okay. Just use STEM the same way. Okay. X, Y, and line spec. Okay, and this is an example here. Okay, plot discrete signal. Okay, okay. Maybe I should explain it. If you have a discrete data, okay, you better to use stem. Okay, this is the discrete data. Okay, continuous data usually we use the plot function. But if you have discrete data, this one is better to use stem. So the same way you use stem plot. So instead of it is the same way. Okay. So you have the x-axis and then you have the y-axis, and then the labeling is also the same. Okay, and then the title. Okay, how to write the title also the same. So this is the result. So you can practice it here. Okay. One more thing, it is highly suggested if you can practice to use this one. Okay. So how to write a title with variable parameter. Okay, I think that's it for stem. Logarithm. Okay, this one is usually for control also. Okay, I should show you logarithm first. Okay, this one is log graph. So you can see here it's not linear. Okay. Okay, I don't have any log example. Okay, it's okay. So it's something like this. Okay, it is linear based on the decade. Okay, so you can see here 10 to the power of 0. Okay, it increased in decade instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is linear. But for logarithm, okay, log graph, I think you already look here. Okay, you already learn about the logarithm. So it should be something like this. Okay. So how to use it? Okay. Okay. So a logarithm scale is a non-linear scale used where there is a large range of quantity. Okay. So commonly used in the character, okay, a quick string, loudness, decibel, pH acidity, and frequency range. Okay, board plot. I think many of you already know what is board plot. Okay, so if you want to use this, you can just write SemilogX or SemilogY. Okay, which one you want to make as a log? Okay, if the x-axis is the log, you just use SemilogX. If your y-axis is the semilog, okay, is the logarithm. Okay, you just SemilogY. Okay, x, y, and line spec is the same. So no need to worry about this. It's the same. Only this one is the different. And if you both are log, you just use log. Okay. So this is an example. Example 9, loudness. Okay, environment loudness was recorded in several occasions below. Plot the data using normal plot and logarithm plot, then compare the two plot. So you have here, you can see here, this is the different, okay, different range. Okay, that's why logarithm is suitable for nonlinear scale, where the large range of quantity. So this is very large, and then this is very small, this is very large. Okay, so this one actually, if you plot in the linear scale, you cannot see anything. But if you plot in the logarithm, okay, this one is log y, semi-log y, because only the y exists in the log. So how to plot this? Of course, you subplot. Okay, this one is the first location, this is the second location. Okay, so you have plot, okay, plot y. So this is the data first. Okay, you collect the data, this is the data, you write it in the MATLAB. Okay, and then the occasion, okay, this one is the string data. And of course, this is double dot is basically just, if you don't want to make it a long code, you just can put the ... here. I think this one is missing comma. Let me check first. Okay, so the coding can run. So basically this one, if you don't want to make it as a continuous, okay, so this is example. So if the code is too long, okay, this one can. But if you don't want to make it too long, you can just put a triple dot and then enter. Automatically it will create a new line, but it's considered as continuous. It still can run. Okay, so avoid confusion. So you can see here, you create a subplot here, position 1. Okay, it will plot the L. Okay, the L, this is the marking. Okay, continuous blue, and this one is the marker O. Okay, so X ticks. Okay, you can see here X ticks. Okay, you have to add the tick first. Okay, you can see here 1, 2, 3, 4, 5, 6. Okay, and then you label the tick with the occasion, this one. Okay, so you just replace this. Okay, so you can see here there is no percent dot something. Okay, because you don't use 1, 2, 3, 4, 5 anymore, you just directly take this value. And then this one is just X label, Y label, and the title. Okay, same here, but this time you use SemilogY. Okay, you put SemilogY, you can see here the plot is much more clear. Okay, this is the second position, of course, and then you create a tick. Okay, this one, the tick 1, 2, 3, 4, 5, and then replace it with the occasion here. Okay, then label and title. So that is how you use a semi-log graph. Okay, how about board plot? Okay, this one is quite popular, board plot. So of course, example 7.6, this one, the same example here. Okay, this one. Okay, and then if you want to plot it in the semilog, okay, of course C is equals to 0.47 microfarad, and then this one 4.7 kilo ohm. E3 means that kilo. E negative 6 means that micro. Okay, F is the frequency, you already know this. Okay, this one already know, this one already know. Okay, this one is just repeated the example 7.6. Okay, but this time you plot using SemilogX. Okay, only the X is the logarithm scale. Okay, and of course you change the tick, okay, to this one, pi. Okay, that's why you divide by pi for the phase. Okay, so this is the result. Okay, let has a break for 5 minutes. Okay, we continue with the last part of spatial plot, okay, which is histogram. So histogram plot could be performed by using histogram function. So histogram function automatically choose an appropriate number of bins with uniform width to cover the range of value. I think most of you already know what is histogram. Okay, this is histogram. Okay, you have multiple data here. Okay, it will sort it accordingly. So you can use this coding histogram x the data, okay, and n bins. Okay, n bins is a scalar defining. Okay, a scalar number means that you can choose a 1, 2, 3, 4, 5. Okay, defining the custom number used to define the bin. Okay, and h is the vector define the edge of the histogram. So you can use two coding. Okay, either histogram or histogram. Okay, capital letter or small letter. Okay, so if you use small letter, this one is the, for example here, if you want to have 1, 2, 3, 4, 1, 2, 3, 4. You want to divide it into 4 category. Okay, you use the small capital and you just write n bin is just 4. Okay, but if you want to use for example, you want to set it 0, 10, 20, 30, 40, the h you use capital letter hash. Okay, histogram, and you write the vector that define the edge. Okay, so you can choose two types of histogram. Okay, so you can see here example, a test score. Below program code visualize the test score class with uniform group into 4 category and 20 score range. Okay, so of course this one you have to recall back chapter 3. Okay, so this one you just create a random mark. Okay, you just create a random mark. Okay, this one it's not available. Okay, you just create any number and then you subplot the first one. Okay, this one is small capital. Okay, sorry, I think there's no need for hash capital and small capital. Okay, either you just write the number here. Okay, it will automatically create 4, or you can just use this one. Okay, the vector. Okay, sorry about that. It's been a long time I use this one. Okay, so you can use histogram also. Okay, you can either use a scalar number. Okay, 1, 2, 3, 4, 5, or you can just put a range. Okay, the vector to divide the mark. Okay, so you can see here. For this one, it use a edge. Okay, from 0, 2, and 2, 4, 6, 10. Okay, each 2 step, and this one is much more larger, and you plot it at the 2 different location. Okay, so this is the result. Okay, since we don't have a data here, so you can just use randy. Okay, random integer. So 1 until 40, because the mark is maximum 40, you just put 40, 1. Okay, 1 row, 20 student. Okay, so you can maybe I just put here. Okay, okay, it will create a random mark here. You can see this is the mark. Okay, and then okay, so you can see here. Okay, you create subplot and then create histogram. Okay, with the divider of 2. Okay, because 0, 2, 4, 6, and so on. Okay, this one is the standard, and then for this one, okay, it's divided into 10 step. Okay, it's divided into 10. Okay, if you don't like this way, you can just divide by 1, 2, 3, 4. So instead of vector, you can just use 4. Okay, it will automatically divide it. Okay, it divide by 4. Okay, so it's the same. So maybe you want to divide by 5, it will become 5. Or you want to put 0. If you want to divide by 5, I think can write 40. Okay, so something like that. Either you use a small scala or vector for the histogram. This one you have to use the capital letter, small letter. Okay, so that is how you create an histogram. Okay, so we have we already at the end of the slide, which is plot editing using plot tool or wizard. Okay, so you have the plot tool here. Okay, you can explore it on your own. Okay, let me show you. Okay, this is the plot. Okay, you can plot this. Okay, you can click this plot properties. Okay, for example, the score. Sorry about that. It's a little bit heavy for the wizard. Okay, so you just click here, score. You can change the size. For example, you want to make it bold. Okay, okay, you make the size larger, 15 for example. Okay, for number of students, you want to change it to 20. Okay, you want to change the color. Okay, so just press this one. This one is the property inspector. Okay, and then you just click the data you want to change. Sorry, my PC not working properly. Okay, now it's gone again. Okay, let me click again. Okay, so you can change anything you want. So for example here, the vertical data, you want to add legend, the mark. Okay, you can explore it. This is just for your practice. Okay, this one usually don't come out in your test or exam. Okay, but it is a useful tool for you. The test will cover the coding only. Okay, this one, the coding, the title, the y-axis, the x-axis, but not the wizard. The wizard is just for your convenience. Okay, so that's it for today. Okay, you can explore the tools yourself, the wizard. Okay, this is the end for chapter 7. Okay, and make sure you slide in your attendance. I will put it in e-learning on the day. Okay, if not available, make sure you remind me again. Okay, I have other meeting at that day. Okay, sorry about that. So let me. Okay, that's it for this chapter. Okay, thank you.